Hello class, let us prove one more identity today. Curl A C is equal to curl A transpose C, where C is a constant vector. C is a constant vector. And what is our capital A? Capital A is a second order tensor. Okay, now C was outside, the C is gone inside that curl. That is the identity we have to prove. And one more thing to observe is that we have in the LHS we have A, in the RHS we have A transpose. Okay, yes. Now, what is A? A is a second order tensor. A is a second order tensor. What is curl A? When you apply curl to any tensor, will the order change? No, the order will not change. Curl A is also a second order tensor. Curl A into C, the ordinary product, right, is a vector. So, our LHS is a vector. So, one free suffix will come, that is I. To take LHS, LHS is nothing but a vector. So, one free suffix, that is I. And that is equal to curl A is a tensor of order 2, right? So, it will have two suffixes. So, IJ. Since I want I here, so for C, I should take J. J has to be dummy. Right? Next step. I want curl A IJ. For curl A, I want IJ. So, I am using the tensor notation for curl of A. Right? That's nothing but one epsilon will come. So, epsilon, right? The first suffix has to be I because there is I here. Because there is I there. So, first suffix must come, that is I. So, I can choose the other two suffixes as whatever we want, right? We'll take it as mn, right? Now, I want the components of the tensor A. So, I'm taking A, small a, second suffix J. So, second suffix J there. Now, we have chosen mn here. So, I should take the reverse n, comma m, comma m. So, that is the definition of curl A ij. Curl A ij. Okay. So, now Cj as it is outside. Fine. Now, Imn will take outside. Now, what is the remaining? Remaining I am writing. So, Ajn, the first term Ajn, comma m, Cj as it is, plus I am adding a term which is nothing but Ajn, Cj comma m. Okay, Cj comma m. And what is our C? C is a constant vector. So, Cj comma means what? Differentiation with respect to xm, right? So, differentiation of constant with respect to xm is anyway 0, right? So, 0 into Ajn is again a 0. I'm just adding a 0 to this. So, therefore, these two are equal. Okay. Now, that is equal to epsilon Imn, epsilon Imn. Now, just watch the terms within the bracket. What is the term within the bracket? So, within the bracket, we have Ajn comma m. Okay. Differentiation of the first term. Cj as it is plus Ajn as it is and differentiation of Cj. So, this is nothing but the product rule. So, we have the product rule. Now, remember in the RHS, I want A transpose. In the RHS, we want A transpose, right? So, A transpose must come here. So, what am I going to do now? So, we are going to interchange, right? Just interchange. So, Jn is there, no? I'm going to put Nj there. So, when you put Nj, A transpose must come there, right? Comma M as it is, comma M as it is, right? Cj as it is, Cj as it is, plus again we have Ajn here, right? Ajn there. So, what am I going to do? So, plus as it is. So, I am putting A transpose When I'm putting A transpose, so I should interchange the suffix, right? So I should take NJ and CJ comma M as it is, right? Now, just watch this now. So we have A transpose NJ CJ. Don't look at commas now. Okay, we have A transpose NJ comma CJ. So that is nothing but the ordinary product A transpose C. A transpose C. Okay, and what is the suffix? Suffix is N. Suffix is N and comma M. Outside comma M. Okay, no? Just using the product rule. Comma M for the whole thing. And this is nothing but the RHS curl, right? A transpose C, right? The whole thing, what component? I component. I component. So I component, and there also it is equal to I component. So therefore we have proved curl A, and C was outside. Now C is gone inside. So curl A transpose C, where C is a constant vector. Very, very important identity. Okay guys, so let's stop now. The next class we are going to prove two theorems. Okay, let us stop now.